is my third milestone video for the third eye for the blind. So this is my final milestone, and I have finished building my project, so now I'm going to give you a quick rundown of how this is going to work. So on the cap itself, there's an ultrasonic sensor, and so I've decided to put it on a hat rather than the original project having it on the hand, because I wanted it to be a wearable device that was also hands-free. So that's where that's located, and the wires go under the hat. So there's holes in the hat right here, and they go under and behind. So these are the wires that are gonna go behind. And then I soldered all of the wires onto this perf board. And so this is where the Arduino is located, and this is what my soldering looked like. And so the vibrating motor is also on this perf board, and this board will be kept in the user's back pocket. So that way when the program runs, they'll feel it in their back pocket, and so they'll be more alerted. And then this was the second vibrating motor that has the switches that I talked about in my second milestone. And so this will most likely be located in the front pocket, so that way the vibrating motors aren't clashing and there'll still be a difference. So it's just like easier to figure out which one is which. And this is where the second vibrating motor is. So for demonstration purposes, I think I'm just going to have these in the front so I can show you what they sound like and how they work. So like I did for my previous milestones, I'm going to be putting the vibrating motor on the table so you can hear it better, and I can also demonstrate how the sensor works. So when it's kept on the table, if something's really close, it still goes really fast and is more alerting. And then as I back away, it slows down. And so that was like the general sensor that we've been working on since milestone 1. And the second vibrating motor is controlled by the switches. And so the first vibration is a lot quicker, and that's if the person would be facing the user. And so it's just more alerting, so they're more aware of what's going on. And then, so I'm going to be demonstrating that first. As you can see, it's a lot faster, whereas the second one is still alerting, but it's a little bit slower. Yeah. And it's just two different frequencies that are displayed whether a person is facing the user or is turned away. So the biggest challenge I faced was just figuring out the wiring when I was soldering the wires onto the perf board, because on this perf board, which has the switches on it, I accidentally ended up soldering all of these in the wrong spot, and I connected them to the wrong wire. So my entire thing was messed up. I had to desolder it, figure out a way to like fix it, and it took me a lot more time than I was expecting. I'm pretty sure I spent at least like 3 to 4 hours just soldering and trying to figure out what goes where. I was trying to be super careful. I also didn't want to burn myself, and so that took a lot of time as well, and that was probably my biggest challenge in the third milestone. So I think overall I've achieved so much from Bluestamp, obviously ending in this final project, and I can't wait to do more. My future steps would probably be to receive a proper people sensor so I can be able to make that functional and also add that onto the design. And so that way it can help even more people. And then also I'd want to find a way to limit the amount of wires I'm using so it's not as messy and it wouldn't get tangled as easily. Overall, Bluestamp has helped me so much, and it was a really great introduction to mechanical and bioengineering for me. And I hope that moving forward, I'll be able to continue expanding on this project like I mentioned earlier, and continue to develop devices that can help more people and help me achieve my passions.